Hey, it's Mr. Estrada here, and I'm going to do the June 2013 geometry Regents in this video. So let's get right to it. Here is number one, and the topic being tested here is the area of a triangle formula. So the question says, if trapezoid RSTV is not isosceles, which triangle is equal in area to triangle RSV? So to help you visualize this, I'm going to take triangle RSV and I'm just going to split it up. I'm going to put it right over here. That's triangle RSV, and this is triangle RST. Okay, now you should know that the height of both of these triangles is the same, right? This height that I just drew right over here is the same as this height. This line is equal to this line. So both of these triangles have the same height. And by the reflexive property, you'll see that both of these triangles also have the same base. So these two triangles have the same height, they have the same base, and since the area of a triangle is half base times height, these two triangles will be equal in area. So the answer is choice 2. Number 2. So we are told here that triangle XYV is congruent to triangle TSV. Now usually when they give you information like that, they're testing corresponding parts of congruent triangles are congruent, or CPCTC. So just to give you an idea of where I'm going with this, just from this statement right over here, I know that angle X is congruent to angle T. Because you see how angle X corresponds to angle T. So since the two triangles are congruent, the corresponding parts are congruent. Just from this statement, I know that XY is congruent to TS, and so on and so forth. So when it says which statement cannot be proven, the statement that cannot be proven is choice 2. All the other choices can be proven because the corresponding parts of congruent triangles are congruent. So choice 2 cannot be proven. It says VYX is congruent to VUT, and there isn't even a letter U in the other triangle. So the answer is choice 2. That cannot be proven. Number 3, in a park, two straight paths intersect. The city wants to install lampposts that are equidistant from each path and also 15 feet from the intersection of the paths. How many lampposts are needed? So this is a locus question. So you want to be familiar with your locus theorems. So let me put those up right now. So here are your basic 5 locus theorems. You got a locus of points, fixed distance from a point, fixed distance from a line, equidistant from 2 points, equidistant from 2 parallel lines, and equidistant from intersecting lines. So with these locus questions, it's a good idea to ask yourself, what locus theorem are they testing me for? And that will give you an idea of the kind of picture you're trying to produce. So if we read the question, it says the city wants to install lampposts that are equidistant from each path. Now, from reading the question, we know that the paths intersect. So I'm going to draw 2 intersecting lines. If I'm going to draw the points equidistant from these paths, I know I got to use locus theorem 5. So I'm going to do just that. I know that I have to produce an image that looks something like this. Now, since I drew my paths like a cross, the locus of points equidistant from that cross is going to look like an X. All right, then let's keep reading. So we got equidistant from each path. That's what I just drew. And it says, and also 15 feet from the intersection of the paths. Now, the intersection of the paths is right over here, and the intersection of the paths is a point. So if I'm going to draw all the points 15 feet from the intersection, I know that should produce a circle. So I'm going to go ahead and sketch a circle. So how many lampposts are needed? You're going to need 4. One here, one here, one here, and one here. Basically, you need a lamppost 15 feet from the intersection of the paths. So that's on the circle, and equidistant from the 2 paths. So it has to also be on the dotted lines. Okay, so for number 4, it says, what are the coordinates of A prime, the image of point A, -3, 4, after a rotation of 180 degrees about the origin? So for a rotation of 180 degrees, we have to only negate the signs of X and Y. So if we negate -3, we will get +3. Negate means change the sign or make it the opposite. And if we negate 4, we're going to get -4. So we get 3, -4 for A prime. So therefore the answer is choice 4. Number 5 says, based on the construction below, which conclusion is not always true? So from the construction of a perpendicular bisector, let me give you a couple of things that are going to be true. Of course, you're going to get perpendicular lines because you just constructed a perpendicular bisector, so you will get perpendicular lines. So this will be true. And then you'll also get a midpoint. E will be your midpoint. That's why it's a bisector, because it intersects the line at the midpoint. So since E is a midpoint, we know that AE will in fact be equal to EB. Now, the other thing that you will also get is that CE will be equal to DE. So E acts also as the midpoint, not only for AB, but it also acts as the midpoint for CD, or the segment that is going to connect the intersection of those arcs. What will not always be true is choice 2. Okay, number 6. Which equation represents the circle whose center is 5, -3, and that passes through the point -1, 3? So they gave us the center, so by them giving us the center, they're giving us H and K. So when we put it into the formula, we're going to get x plus 5. So we get x plus 5 squared plus y minus 3 squared. So we get x plus 5 squared plus y minus 3 squared. Now, if you're wondering why those signs changed, is because if you substitute a -5 for h over here, you're going to get a subtraction sign followed by a negative sign, and then that's what makes it positive. And if you substitute the 3 in here, you get a -3. Now, just from doing that simple substitution, we know that the answer cannot be choice 1, we know the answer cannot be choice 2, and we know the answer cannot be choice 4. So the answer is choice 3 by process of elimination. But if you're wondering how would you go about finding the radius, you can go about finding the radius if you just sketch the 2 points and then you just count from the center, so this is the center, to the point on the circle, and you would get a distance of 4, and you're supposed to square the radius, so you would get 16. Number 7, it says, as shown in the diagram below, when right triangle DAB is reflected over the x-axis, its image is triangle DCB. Which statement justifies why AB is congruent to CB? Now, for this question, you only need to know that in a reflection, distance is preserved. But I'm writing all this other stuff here just so you know, okay? So the answer to number 7 is choice 1. The reason why AB will be equal to CB is because in a reflection, the distance is preserved. The distance will not change. So that's the answer to number 7. Okay, so for number 8, we have to figure out what type of triangle ABC is. So in order for us to do that, we have to solve for x and then substitute to get angle measurements. So let's combine the x's. We got 3x plus 4x plus 5x, that gives us 12x. Then we got 1 minus 17, that's negative 16. Negative 16 minus 20 is negative 36. So I write minus 36 equals 180. Then we got to solve for x, so x equals 18. Right, yes, x equals 18. Okay, now let's find our angle measurements. So angle A is 3x plus 1. So we got to sub for x here. So that's going to be 3 times 18, which is 54. And then 54 plus 1 is 55. So angle A, forgot my A there. So angle A is 55 degrees. Okay, so from these measurements, we know we're dealing with an isosceles triangle because an isosceles triangle has 2 equal angles. And so it's not a right because it doesn't have a 90-degree angle. If it had a 90-degree angle, it would be a right. It's not scalene. In a scalene, all the angle measurements are different from each other. So it's not scalene because we got 2 angles that are the same. And it's not equilateral. For it to be equilateral, all the angles have to be the same. So for number 9, it says, what is the equation for circle O shown in the diagram below? So we got to produce the equation. So we need to find the center. So the center is 3, negative 1. And the radius is 3. So when we substitute, we will get x minus 3 squared plus y plus 1. And again, the reason why it's plus is because you have a subtraction followed by the negative sign, and that will make it plus. So you get y plus 1 squared equals the radius squared. The radius is 3, so we get 9 here. So the answer is choice 3. Number 10, it says point A is on line M. How many distinct planes will be perpendicular to line M and pass through point A? So here is line M, and it's just an arbitrary line, and we have point A on it. Now, regentsprep.org has a nice little unit on planes. So this comes from regentsprep.org. And if you look at this particular theorem right over here, this one here, the one on the upper right corner, it says through a given point there passes one and only one plane perpendicular to a given line. So if you think about it, this is like our line M, and then that's our point A. You can only draw one plane perpendicular to that line, and that passes through that point. So the answer is going to be choice 1. Number 11, in triangle ABC, D is the midpoint of AB and E is the midpoint of BC. So just off of that, I know that I'm dealing with a midsegment here. All right, and it says AC is 3x minus 15, so this is 3x minus 15. And it says DE is 6. What is the value of x? So here's the deal. A mid-segment is half of the base. So DE is half of AC. So I know that if I want to make some type of equation, I have to multiply 6 by 2 so I could set it equal to 3x minus 15. So 6 times 2 is 12. So I get 12 equals 3x minus 15, and just go ahead and solve for x. So our answer is choice 3, 9. Number 12, so this is just a midpoint formula question, so we're going to go ahead and substitute. So when we substitute, we get this. 8 plus negative 3 is 5, so we get 5 over 2. For the x-coordinate, for the y-coordinate, we got negative 4 plus 2, which is negative 2 over 2. So 5 divided by 2 is 2.5, so we know it's not choice 3 or 4. Negative 2 divided by 2 is negative 1, so our answer is choice 2. So for number 13, we got ourselves a nice system of equations question here. And we're just looking to see what kind of graph this parabola and this line is going to produce, what it will look like. So let's figure out what it will look like. But before we do that, we got to put this in y equals form, and when we do, we subtract x on both sides, and we will get y equals negative x plus 2. So we get our graphing calculator, input that, press y equals, and input your equations into y1 and y2, then you hit graph. That's what our graph looks like. So the answer is going to be either choice 2 or choice 4. Now, they sort of look alike, but upon further observation, you'll see that the parabola actually goes below the x-axis. So the answer is choice 2. Number 14 says, what is the converse of if an angle measures 90 degrees, then it is a right angle? So for the converse, you want to switch the intro and the conclusion. So the converse will be, if the angle is a right angle, then it measures 90 degrees. So the answer is going to be choice 1. Okay, so for number 15, it says, as shown in the diagram below, a right pyramid has a square base, A, B, C, D, and EF is the slant height. Which statement is not true? So I'm just going to go ahead and use process of elimination for this. Which statement is not true? So it says EA is congruent to EC. Yes, that will be true. The reason why EA is congruent to EC is because the lateral faces of a pyramid are congruent isosceles triangles. So this is indeed the same as that because they are corresponding parts of congruent triangles. Okay, then it says EB is congruent to EF, and that's not true. And you actually don't need to know anything about pyramids to know that. If you look closely, you can see EB is the hypotenuse of a right triangle, and EF is a leg of a right triangle. So by definition, the hypotenuse is longer than any of the legs. So the answer is choice 2. Choice 2 is not true. Number 16 says, what is the equation of the line passing through the point 6,1 and parallel to the line whose equation is 3x equals 2y plus 4. So I have a whole video on this. If you search parallel line to a point in my site, our first step is to put this in y equals form. So we got the 2y plus 4 on the right side of the equation. So we want to move the 4 to the other side because we want to get y by itself. So if I bring everything down, I get 3x minus 4 equals 2y. Then I'm going to go ahead and divide everything by 2 to isolate the y. This will cancel out, and I will get 3 over 2x minus 2 equals y. Or let me just bring the y to this side since everybody's so used to seeing it that way. All right, so that's the original equation. Now, we're looking for a line that's parallel to this. So we're looking for some line in y equals mx plus b form that's parallel to this. So we know that this line we're looking for needs to have the same slope as that. And it has to pass through this point. So I know that x at some point in that line equals 6 and y equals 1. So when I substitute to solve for b, I will get 1 equals 3 over 2 times 6 plus b. So now I'm going to go ahead and solve for b. I get 1 equals 9 plus b. I'm going to subtract 9 on both sides. So 1 take away 9 is negative 8. So negative 8 equals b, and this is the m. So the answer is choice 3. Number 17 says the volume of a sphere is that, so I know V equals, let me go ahead and just write that down here, V equals 44.6022, and we're being asked for the radius. So if I substitute the volume into this, I'm able to solve for the radius because there's only one unknown in the equation. So I get 44.6022 equals, so I gotta isolate the r, so I'm gonna go ahead and divide both sides by 4/3 pi. So both sides are gonna get divided by 4/3 pi. And that will cancel this out, that will cancel this out, and I'll be left with r cubed on the right side of the equation. So now, what's 44.6022 divided by 4/3 pi? Well, let's get our calculator for that. Let's put it to good use. So we have 44.6022 divided by, so what I want to do here is I want to put the 4/3 inside parentheses. So divided by 4/3 pi, and I get this number. And I'll just go ahead and round that to 3 decimal places just to be safe. So I get 648. So I get 10.648. Now, I got to solve for r. So r is being raised to the 3rd power here. So I'm not going to square root both sides, okay? I'm going to cubic root both sides, which is not the same as square rooting. So I'm going to cubic root. So you got to do the cubic root here. So when you square something and you want to do the opposite, you square root. When you raise something to the 3rd power and you want to do the opposite, you got a cubic root. So to do that, I'm going to go to math, and right over here you'll see the cubic root, and I'm going to type in 10.648, and I get 2.2. So 2.2 equals r. Hope that's an answer choice, and it is. So the answer to number 17 is choice 1. Okay, so for number 18, we are given points on line AB and line CD, and then we're being asked if the lines are parallel, perpendicular, the same line, or if they just intersect but are not perpendicular. Now, in order for us to make that assessment, we have to find the slopes of each of the lines. So the slope, by the way, M means slope, not measurement in this context. M means slope. So M of AB, the slope of AB is going to be 6 minus 3 over 7 minus 5. And I'm just using the slope formula here. So that's 3 over 2. The slope of CD is going to be 0 minus 4 over 9 minus 6, which is negative 4 over negative 3. Negatives cancel out, so it's just 4/3. So these lines are not parallel because the slopes are not the same. They are not perpendicular. They are not the same line because they don't even have the same slopes. So the answer is choice 4. Number 19 says, which set of equations represents 2 circles that have the same center? Okay, that was easy. The answer is choice 4, right? If you recall, the equation of a circle is x minus h squared plus y minus k squared equals r squared. The center of a circle is h and k, so we're looking for the h and k's to be the same, and you can see here h and k are the same. There are only 5 ways to prove parallel lines, and I listed those 5 ways here. So let's use process of elimination and eliminate the choices that are not found in our list to prove parallel lines. So choice 1 says angle 2 is congruent to angle 4. Those are vertical angles that are congruent, and vertical angles do not prove parallel lines. Choice 2 says angle 7 is congruent to angle 8. That's a linear pair and they're supplementary, and those do not prove that the lines are parallel. Choice 3 says angle 3 and angle 6 are supplementary. So those are same side interior angles, and if they're supplementary, that would prove that the lines are parallel. See over here, same side interior angles are supplementary, that would prove parallel lines. Now choice 4 says angle 1 and angle 5 are supplementary. Actually, angle 1 and angle 5 are corresponding angles, so the answer is not choice 4. So for number 21, we got ourselves a triangle inequality question, so it's a good idea to just draw yourself a triangle and label the given angles. My picture is not drawn to scale. That's okay, because we're going to use the given measurements to determine what is the longest side, what's the shortest side, and what's the medium side. All right, so the longest side is opposite from the biggest angle. So the biggest angle is 80. That means the longest side is AC. So AC has to be greater than any of the other sides. The shortest side is going to be side AB. And the reason why that is because the smallest angle is angle C, and opposite from angle C is the side AB. So AB has to be the lesser side of all of them. And then the side that's left is side BC, so side BC has to be here. So the answer is choice 2. Choice 2 is the only one that says something that's true, right? It says AC is bigger than BC, and that's true. Choice 1 says AB is bigger than BC. That's not true. AB is the smallest side. Choice 3 says AC is less than BA. That's not true. AC is the biggest side. And choice 4 says BC is less than AB, and that's not true either. Side BC is bigger than AB. All right, number 22. So we got ourselves inscribed angles, and we have ourselves a central angle as well, and it says what's the ratio of angle AOC to angle ABC. All right, so here's what you need to know, right, in regards to inscribed angles. The inscribed angle is half of the intercepting arc. All right, so the inscribed angle is half of the intercepting arc. Another way to think about it is to say that the arc is twice the inscribed angle. So what's our answer? Well, since they want us to give the ratio of angle AOC to ABC, angle AOC is the same as this arc over here. So let's just go ahead and call angle AOC, let's make up a variable, let's call it X. Or you know what, I want to call it 2X. Let's call it 2X. So angle AOC is 2X. That means this arc is also 2X because the arc is the same as the central angle. However, though, the inscribed angle is half of the intercepting arc. So the inscribed angle will be 1x. So what's the ratio of AOC to ABC? It's 2x to 1x, or you could just say it's 2 to 1. Number 23 says a rectangular prism has a base with a length of 25 and a width of 9 and a height of 12. All right, so our first prism. So what is the volume of our first prism? Well, we have to, so the volume of all prisms, it's the area of the base times the height. So the area of the base will be 25 times 9, and 25 times 9 is 225, and then 225 times 12 is 2700. How about the second prism? Well, that's what we gotta look at for a second. It says a second prism has a square base with a side of 15. So from that, I know that the length and the width of the base is going to be the same because it's a square base, so the length and the width are the same in a square. So this is 15 and this is 15. Then it says if the volume of the two prisms are equal, so that means the volume of prism 2 is 2700, what is the height? All right, so we're going to have to go ahead and do some algebra. So volume is going to be the area of the base, so that's going to be 15 times 15, which is 225, times some height. Well, I know what the volume is, so I could substitute for the volume here with 2700. And now all I have to do is just solve for h. So I got 2700 divided by 225, and that's 12. So the answer is choice 3. Number 24, in triangles ABC and DEF. So let's go ahead and draw two triangles not drawn to scale. So we got triangle ABC, and we got triangle DEF. And here's what it says. It says AB is 4. It says AC is 5. And it says DF is 10. And it says, oh, and then it said DE is 8. Forgot about DE. Okay, and then we also know that angle A is congruent to angle D. So then it says, which method could be used to prove that these triangles are similar? Well, that would be the side angle side method. So the side angle side method in similarity is not the same as the side angle side method in congruency. The side angle side method in similarity says that if two sets of sides are proportional and the included angles are congruent, then those two triangles are similar. And that's what we have here. We have proportional sides and the included angle congruent. So it's side angle side. Number 25. Which graph represents a circle with this equation? So from this equation, we know that the h is 0. And we know that the k is 1. So we got to change the sign of that. And we know the radius is 3. So our answer is choice 1. 0, 1 is the center, and then the radius is 3. So when they give you the equation, don't forget you got to change the signs of h and k. The reason why h is 0 here is because it's just x squared by itself. So the h is 0. Okay, number 26 says, what's the perimeter of a rhombus whose diagonals are 16 and 30? Okay, so you got to know two things about the diagonals of a rhombus here. First, the diagonals bisect each other. So if the longer diagonal is 30, so this is the longer diagonal, so I know that this has to be 15 and 15. And then for the shorter diagonal, I know this has to be 8 and 8. So that's the first thing you need to know about the diagonals of a rhombus, that they bisect each other. The second thing you need to know is that the diagonals of a rhombus are perpendicular. That's going to come in handy because now we can use Pythagorean theorem to find the side C. So we could say 15 squared plus 8 squared equals C squared. 15 squared is 225. 8 squared is 64. Bring down the C squared. 225 plus 264 is 289. So 289 equals c squared. The square root of 289 is 17. So 17 equals c. Now, if this is 17, recall that in a rhombus, all the sides are congruent. Remember that? So the perimeter is going to be 17 times 4. And then 17 times 4 is 68. So the answer is choice 2. So for number 27, we have ourselves overlapping right triangles question. And for this question, we are being asked to find the length of AB. So I'm going to go ahead and label ABX. All right, now, what I like to do with these questions is make myself a chart. So for the columns, I got small, medium, large. And what that means is I have a column for the small triangle, the medium triangle, and the large triangle. And then on the rows, I got short leg, long leg, and hypotenuse. And that's because each individual triangle comes with a short leg, a long leg, and a hypotenuse. So let's begin to fill in this chart with the measurements we have for each respective triangle. So for the small triangle, the short leg is 3. So the small triangle is triangle ABD, and then you can see that 3 is the shorter leg, so I'm going to write 3 here. The long leg is blank, and then the hypotenuse is X. All right, now let's look at the medium triangle. So for the medium triangle, the short leg is blank, but the long leg is 12. So I'm going to write 12 for the long leg, and the hypotenuse is blank. So I'm going to just leave that blank. And again, right, I know that this is the hypotenuse because it's opposite from the right angle. So that's the hypotenuse of the medium triangle. Now, for the large triangle, I'm going to start with the hypotenuse. The hypotenuse of the large triangle is 15, right? And this whole line is the hypotenuse. So I'm going to write 15 here for the hypotenuse. Now, the long leg is blank, but the short leg is X. So I'm going to write X here. All right, now from this chart, these are going to give me a proportion. So I can write 3 over X equals X over 15. So that's exactly what I'll write. 3 over X equals X over 15. And then I can do that because these are all corresponding sides. So I get X squared equals 15 times 3, which is 45. So now I got to break down 45. So the square root of 45 can also be rewritten as radical 9 times radical 5. Radical 9 is 3, so I get 3 radical 5. The answer is choice 3. So for number 28, I have a circle. And then it says you got secant JKL. And you got JMN. And they're both drawn from the same external point, J. So the external point is J. So I'll make the top secant JKL, and I'll make the bottom secant JMN. So it says JK is 8, LK is 4, JM is 6, and then it says what is the length of JN? So I'm going to go ahead and label JN X. So recall the formula. So the formula is external secant times the whole secant equals external secant times the whole secant. So let's begin with the top secant. The external secant is 8, and the whole secant is 8 plus 4, because you got to add 8 and 4 to get the whole secant. So 8 plus 4 is 12, so we get 8 times 12 there. For the bottom secant, the external secant is 6, and then the whole secant, we labeled it x. So we got 8 times 12, which is going to be 96. So we get 96 equals 6x. And then we're going to go ahead and divide both sides by 6 to get x. And we're going to get x equals 16. So the answer is choice 1. Number 29. So now we're here, we're at the short responses. So it says a right circular cylinder has a height of 7 inches. So the height equals 7. The base has a diameter of 6 inches. So if the diameter equals 6 inches, we know from that the radius equals 3, which is what we need. We need the radius, not the diameter. So it says determine the lateral area in terms of pi. So we're going to get L equals 2 pi times the radius times the height. So we got 2 times 3, which is 6. 6 times 7 is 42. So we get 42 pi as our final answer. So L equals 42 pi. Number 29. It says determine in degrees the measure of each interior angle of a regular octagon. So n equals 8. So if you want the sum of the interior angle, so the sum, keyword, the sum of interior angles is equal to n minus 2 times 180. That's a n, pardon my sloppy handwriting. So that's n minus 2 times 180. So then we're going to get, when we substitute, 6 times 180. So we get 6 times 180. So that's going to be 1080. Now 1080 is the sum. We want to figure out what one of them measures. We want to know what one of them measures. So we got to take 1080 and now we have to divide it by 8. So let's go ahead and do 1080 divided by 8. That's 135. So each interior angle is 135 degrees. So for number 31, we got ourselves a distance formula question, and we want to find the distance of AC. So if that's the case, we know that we got to only focus on the coordinates of point A and the coordinates of point C. So I'm going to go ahead and label this x1, and this will be y1. So we got x1, y1. And then this will be x2, and this will be y2. So when we substitute, we get 7 minus 3 squared plus negative 8 minus 0 squared under the radical. So let's simplify. 7 minus 3 is 4, so we're going to have 4 squared plus negative 8 squared. So now 4 squared is 16. Negative 8 squared is 64. Please keep in mind that when you square a negative number, you will get a positive number. So we got 16 plus 64, and then 16 plus 64 is going to give us 80. So we get radical 80. All right, now we have to break down radical 80. So we have to find the easiest way to do this is to find the largest perfect square that goes into 80. And the largest perfect square that goes into 80 is going to be 16. So this can be rewritten as radical 16 times radical 5. Radical 16 is 4. So we get 4 radical 5 as our final answer. So for number 32, we have ourselves a construction. So it says to construct an equilateral triangle with a vertex at R. The length of a side of the triangle must be equal to a length of the diagonal of rectangle ABCD. So let's so here's what we'll do. What I'm going to do is I'm going to just go ahead and draw the diagonal here. Our equilateral triangle, each side must be the same length as this diagonal I just drew. So what you want to do then, right, since you're doing this construction with a compass and paper, what you want to do is you want to take your compass and you want to open it the same exact length of that line you're trying to get. So let me just go ahead and do that. Hopefully my compass will open wide enough. And I think it opened just enough. So basically, so what we want to take our compass now, right, with the same exact opening, and then using our compass, we want to place it on point R, because it says here that they want the equilateral triangle with a vertex at R. So let's construct an equilateral triangle. So the construction of an equilateral triangle is put the point there and swing an arc, and then do the same thing on this point right over here, this point of intersection between the arc and the line. And then finally just connect from here to where the arcs meet, and from where the arcs meet to this point. And there's your equilateral triangle. So for number 33, we have ourselves a locus question. And the first locus condition says to graph the locus of points 4 units from the x-axis. So in order for us to do this, we have to sketch the locus of points a fixed distance from a line. So doing that will produce 2 lines. And in this case, the 2 lines must be 4 units away from the given line, which in this case is the x-axis. So that's the first part. For the second part, we have to sketch the points equidistant from 2 points. So the 2 given points are -2, 0 and 8, 0. So equidistant from these 2 points will produce a line right through the middle. So we should, let me just go ahead and count how far apart these points are. They're 10 units apart. So it should be 1, 2, 3, 4, 5. So I should draw a line right through here. So then it says mark within X all points that satisfy both conditions. So that would be here and here, where the dotted lines meet. So for number 34, it says the coordinates of 2 vertices of square ABCD are A, 2, 1 and B, 4, 4. Determine the slope of side BC. All right, so here's the deal, right? I drew a square to sort of give us a visual here. And I'm going to go ahead and label the vertices. But before I label the vertices, I got to tell you, when a figure is 4 sides and up, the vertices must be labeled either in clockwise or counterclockwise order. So I'm going to label that A, B, and then the C has to go here, right? Because I'm going in clockwise order. So A, B, C. All right, now it says that the coordinates of AB are 2, 1. And the coordinates of B are 4, 4. Now you could have done this in a coordinate plane. Maybe that would have been better, but it's not necessary. what's necessary is for me to find the slope of AB. So using the slope formula, we're going to get 4 minus 1 over 4 minus 2, and 4 minus 1 is 3, and 4 minus 2 is 2. Now think about it. If the slope of this line is 3 over 2, what must be the slope of line BC? Well, remember, this is a 90-degree angle because it's a square. So that means the slope of side BC is the negative reciprocal of AB. So the slope of BC, so I'm going to write here, slope of BC is equal to negative 2/3, the negative reciprocal of that. This is a composition of transformations. And when we do composition of transformations, you always start with the rightmost transformation. So in this case, we got to start with the dilation. So when I dilate these points by a half, I'm multiplying by a half or dividing by 2. So after you dilate, you're going to get this. This is what the dilation by a half produces. All right? So the rightmost is what you begin with. So I took the original points, multiplied by a half, and I got these points. Okay, then you want to do the translation, but you want to do it to the dilated points, to the transform points. So the translation is, the rule is 4 comma negative 2. And what that means is that to each of these coordinates, to each of the, let me be more specific, to each of the x coordinates, you're going to add 4. So to each of the x coordinates, you're going to add 4. And then for each of the y coordinates, you're going to subtract 2. So subtract 2 from each y. So doing that will produce these points right over here. So this is our final answer. Sorry about that. That's our final answer. All right, so for number 36, to answer this question, you need to know that segment CF is congruent to segment DF. And same thing on the other side. Segment AE is congruent to segment EB. And then all these segments, they're all basically congruent to each other. So they all get the same tick mark. All right, then we're going to label the given information. We are given that OF is 16. Oh, and by the way, I also forgot to mention that OF is congruent to OE. So we can say OE is 16 as well. That's going to come in handy later. All right, so OF is 16, OE is 16. Let me rewrite that 16. Okay, then it says CF is y plus 10. So CF is y plus 10, so I'm going to write y plus 10 here. That says y plus 10. I can write the same for DF, because these two are equal to each other. And I can even do the same for AE and EB. But I won't, because I don't need to do that at this point. Then it says CD is 4y minus 20. So CD, this whole segment, is 4y minus 20. Now, using the partition postulate, I know that y plus 10 plus y plus 10 equals 4y minus 20. So from that, I get 2y plus 20 equals 4y minus 20. Did you see how I got that? This part, df, plus this part, fc. So that's y plus y, get 2y, and then 10 plus 10, I got that 20. So this part plus this part equals the whole. So that's how I got this equation. So now I got to solve for y. So I'm going to do plus 20 on both sides. And I'm going to subtract 2y on both sides. This will cancel out. this will cancel out. I get 40 equals 2y, and I get y equals 20. So if y equals 20, that means the f is going to be 20 plus 10, which is going to be 30, right? Yes, so df is 30. 20 plus 10 is 30. Okay, so what that means is that these segments are 30, 30, this is 30, this is 30. All right, and then we are being asked to find OA. So to find OA, we're going to have to use the Pythagorean theorem. So it's going to be 30 squared plus 16 squared equals OA squared. So 30 squared is 900, and then 16 squared is 256 equals OA squared. 900 plus 256 is going to give us 1,156. So I get 1,156 equals OA squared, and I got to square root that to get OA. So the square root of 1156 is 34. So 34 equals OA. That's the answer for that. All right, let's move on to number 37. So for number 37, you need to know that in similar figures, the corresponding angles are congruent. So it says here that RST is similar to ABC. So what do I know from that? Well, from that, I know that angle C is equal to angle T. I know that angle B is equal to angle S, and I know that angle A is equal to angle R. So let me go ahead and do that again. Just try to color coordinate it so you can see better. So angle C is equal to angle T. Angle B is equal to angle S, and I know that angle A is equal to angle R. So if I want to solve for X, I can set angle A equal to angle R. So I can write x squared minus 8x equals 5x plus 30. So I'm going to go ahead and solve for x here. So I'm going to subtract 5x here, subtract 5x here, and I'm going to also subtract 30, just get that out of the way now. And you know, I have to do this because I need to set it equal to 0 to solve this quadratic. So I get x squared minus 13x minus 30 equals 0. So now I have to factor. So I get x, and I'm going to use 15 and 2. And since they have to add up to negative 13, that has to be negative, that has to be positive. So I'm going to get x equals 15 here, and x equals negative 2. And I'm going to reject the negative. So since x equals 15, I can now find angle C by substituting for x. So angle C is going to be 4 times 15, which is 60. Sorry about that. So it's going to be 4 times 15, which is 60, minus 5. So angle C is 55 degrees. That's the final answer. Okay, so now we are up to our last question. And we got ourselves a proof here. And I went ahead and I wrote out the proof. And let me just go ahead and explain each one of my statements and reasons. All right, now look, anytime you have overlapping triangles, it's a good idea to separate them. So this over here is TAM, and then this over here is BMA. All right, now from that separation, you can see already that AM is congruent to MA, and then that's how I get this reflexive property here. You see that there? This is the same line, right? And the reason why is since the triangles are overlapping, triangles, since they're overlapping, that shared side is gonna be present for both of the triangles, so you have a reflexive property. All right, then I wrote here B is the midpoint of MH. And we know that's true from the definition of the median, right? The median connects a vertex and the midpoint on the opposite side. So B is a midpoint. We know T is a midpoint because of a median. So we know this is a midpoint, this is a midpoint. Now that's going to come in handy in a second. You'll see how. So we know B and T are midpoints. Okay, now since B is a midpoint, we know that MB is half of MH. And since T is a midpoint, we know that AT is half of AH. That doesn't make sense. Just pause, rewind, and think about it for a second. All right, now we can say that MB is congruent to AT because of the multiplication postulate. So MB is going to be congruent to AT because of the multiplication postulate. You can actually Google that if you're not familiar with that. Regents Prep has something nice about it. So if you Google multiplication postulate, Regents Prep, you'll find something. I'm not going to go into detail here because I've covered that in class already. Now, we can also say angle BMA is congruent to TAM because the base angles of an isosceles triangle are congruent. So remember that since this triangle is isosceles, this angle is going to be congruent to this angle, right? So we know this is congruent to that. So we got side angle side congruent to side angle side. And then that's why I ended up saying the triangles are congruent by side angle side. And then, since the triangles are congruent, the corresponding parts are congruent. That's how I get my eighth statement. So angle MBA, which is this angle here, is congruent to angle ATM because of the CPCTC postulate. All right, that concludes our video. I hope this helps. Take care.